This diagram illustrates the building block philosophy used in structural certification, where confidence in an aircraft's strength and safety is built progressively from simple to complex. Certification starts at the bottom with coupons and elements, where basic material properties and joint behaviors are proven using small generic specimens and data-driven tests. That understanding is then carried upward to details and subcomponents, where real structural features like joints, cutouts, and load paths are tested to confirm that local behaviors scale correctly. Finally, components and full structural features are validated at the top, using fewer but more representative tests to show that the complete structure behaves as intended under realistic loads. The philosophy ensures that by the time a full aircraft structure is approved, its behavior is not assumed or extrapolated blindly, but is firmly anchored in verified material data and progressively validated structural evidence. When the Airbus A310 was certified in the 1980s, its structure underwent full-scale fatigue and damage tolerance tests to demonstrate that it could sustain small cracks without sudden failure long enough to be inspected and repaired. Engineers collected data on crack growth and load distributions, proving the aircraft met the damage tolerance philosophy long before it entered commercial service. This real testing, in addition to computer analysis, ensured that regulators and Airbus agreed the structure was safe for decades of daily operations. Aircraft structures aren't designed perfect. They are designed to handle real life, including tiny flaws. Certification philosophies like safe life, fail-safe, and especially damage tolerance help make sure that even if small cracks happen, the airplane stays safe until we find and fix them.